I put sections 3.5 and 3.6 together in a video because 3.5 is really short and we've talked about it before. It has to do with the square root property. And we know that if x squared equals k, then how do you undo a square? You take the square root. So if x squared equals k, then that means x is equal to the positive or negative square root of k. We talked about how if x squared is equal to 9, there are two integers such that when they are squared will give you a positive 9. Positive 3 and negative 3, right? And we take into account the fact that there's a positive and a negative root when we say x is equal to the positive or negative square root of 9. Quadratics are going to have two solutions. Sometimes they're repeated, the same one twice, but there's always two. So, if we want to solve one like 3x squared equals 12, we're not ready to take the square root of both sides yet because we haven't isolated the perfect square. So let's go ahead and divide both sides by 3, and then we'll have x squared equals 4. And then we can use our square root property. X is equal to the positive or negative square root of 4, and as we know, the square root of 4 is 2. So my solution set is positive or negative 2. And I believe in Alex, you do have the option to state both answers using that positive negative sign. Okay, so now let's look at this one. This one says solve x squared plus 25 equals 0. Okay, so I need to get that x squared by itself, right? So I'm going to subtract 25 from both sides. So x squared equals negative 25. Now, we talked about how when we were looking at functions that we didn't want to take the square root of a negative number because it wasn't a real solution, right? So if I take the square root of both sides, I'm going to get positive or negative the square root of negative 25. Now, there is no real number that when multiplied by itself would give me a negative 25, right? But what we're going to do is we're going to take this and we're going to write it as negative 1 times 25. And now we need to talk about what the square root of negative 1 is defined to be. The square root of negative 1 is defined to be I, or the imaginary unit. Doesn't mean it doesn't exist. It was called the imaginary unit because people thought, well, that can't be real, right? And so, but actually, it's a very useful number, I is, in the theory of electricity and a lot of physics applications, and we're going to see it quite a bit in the rest of the class. So, that would also imply that I squared, if I square a square root, it gets rid of the radical, right, is equal to negative 1. So those are two facts that you need to commit to memory. The square root of negative 1 is defined to be I, the imaginary unit, and I squared is negative 1. So let's go back to our problem. We know that the square root of negative 1 is equal to I, and the square root of 25 is equal to 5. So we can go ahead and say that this is going to be equal to positive or negative, square root of 25 is 5, square root of negative 1 is I. And it's typical to put the I after the 5 as if it were a variable. So the square root of negative 25 is actually defined to be 5i, which is an imaginary number. So my solution set is positive or negative 5i. Okay. So that's just something to tuck in the back of your mind. You know, if we're talking about functions, we want to be able to graph those functions, and imaginary numbers don't show up on the plane. So we typically only talk about imaginary solutions when we're talking about solving equations, not if we're talking about functions. Okay, so now let's go ahead and solve this one. And I want you to notice a pattern here. I have an expression that's squared equal to a constant. So instead of x squared, I have x plus 7 squared equals 8. So I can go ahead and I can take the square root of both sides. We don't usually write it, but we can go ahead and write it on this side. Positive or negative square root of 8. So then I'm going to get x plus 7 because that square root undoes the squaring, equals the positive or negative square root of 8. And as we know, square root of 8 is not in simplest form because 8 is equal to 4 times 2. So I've got one that's a perfect square and one that's not. So that's going to be that x plus 7 is equal to the positive or negative, square root of 4 is 2, square roots of 2. Okay, we're almost there because we want to solve for x. So we need to go ahead and subtract 7 from both sides. And it looks weird if I put this in the front. So I'm going to go ahead and put the negative 7 in the front. X is equal to negative 7 plus or minus 2 square roots of 2. That's the same thing as if I had said positive or negative 2 square roots of 2 minus 7. It just, it looks cleaner this way. So my solution set includes those two answers, negative 7 plus 2 square roots of 2 and negative 7 minus 2 square roots of 2. Okay, let's look at the next one. So for this one, what am I going to want to do first? Ask yourself, what should I do first? Well, I do see an expression involving x that's a perfect square and a constant, right? But I need to get the perfect square by itself, so I'm going to go ahead and add 7 to both sides. Add 7, I'm going to get that, right? Now I can go ahead and use my square root property. Don't really need to put the radical over there, but we can. We could just jump to 5x plus 3 equals positive or negative square root of 7. Now that's not going to simplify, right? But remember, we're trying to solve for x. So the first thing we're going to do is subtract 3, and again, we're going to put it in the front. So that's going to be 5x equals negative 3 plus or minus the square root of 7. And then we need to divide everything by 5, right? So we're going to put a big division bar. We're going to get that x is equal to negative 3 plus or minus the square root of 7 all over 5. And so that would be my solution set. Okay, so just one extra step with that one, right? Now, example 5. If you wanted to, it might be a good idea to go ahead and pause the video and see what you can come up with. Or if you're not comfortable because you see fractions, just follow along with me. So even though I see fractions, I do notice a perfect square with an expression involving my variable inside and a constant. So I'm going to go ahead and I'm going to subtract 7/9 from both sides. Okay. So now I've got perfect square equal to a constant. And I know I'm going to come up with an imaginary solution, right? Because of this negative. Because the next thing I'm going to do is I'm going to take the square root. Okay, so a couple things going on with this. First thing I notice is that negative. And whenever I see a negative, I need to go ahead and think of it. I'm going to go ahead and write y minus 8/3, positive or negative. And then I can go ahead and anytime I have a radical like this, where it's over a fraction, I can go ahead and take the square root of the top divided by the square root of the bottom. So positive or negative, negative 7 is going to be negative 1 times 7 over the square root of 9. Okay, so I know what the square root of negative 1 is, it's I. And I know what the square root of 9 is, it's 3, right? So I'm going to have 8y minus 8/3 equals positive or negative. I'm going to put the I in front of the radical. I'm going to talk about y in a second. And then the square root of 9 is 3. So again, the square root of negative 1 is I. 7 is not a perfect square, right? So it has to stay under that radical. And then the square root of 9 is 3. And, we could put the I in the back, but we want to make sure that we notice that the I isn't under the radical, right? So we can put it in the front. That's usually how you'll see it. And then finally, we want to get the y by itself, right? So we need to just add 8/3 to both sides. Oop, keep doing that. So y equals 8/3 plus or minus I squared roots of 7 over 3. And then if you want, you don't have to, but you've got a common denominator there. So you could write it as 8 plus or minus I squared roots of 7 all over 3. Either one would be fine. And there's your solution set. You have two answers there. So, we went from very, very simple through defining our imaginary unit to then looking at problems where the expression that's squared isn't just an x, right? To finally, the most complicated one where we had imaginary numbers, the expression being squared wasn't just my variable, and I had fractions, right? But as long as you are not breaking the rules, right, and you can take as many steps as you need to take in order to get to the answer. But it all works the same, right? Just have to learn all the details. Okay, so that was section 3.4. This is 3.5. This is 3.6. Solving quadratic equations by using the quadratic formula. And this is something that you are going to have to commit to memory. You must learn the quadratic formula, all right? I know it looks kind of complicated, but you're going to be using it so much that you'll learn it pretty quickly. And the easiest way to learn a formula like that is every time you use it, write it and say it. Don't look at a note card and just copy it. Write it and say it. Write it and say it. And then it's getting into your head through your ears, and your mouth is using the words, and your hand is writing it all the different ways. And the nice thing about the quadratic equation is, if you write your quadratic in this form, general form, right, ax squared plus bx plus c equals 0, then you can solve any quadratic equation at all by plugging in a, b, and c to the quadratic equation and simplifying it. So the steps are, first, set your equation equal to 0, determine the values of a, b, and c, plug them into the formula using parentheses around your numbers, and then simplify. And I'm going to sing a little song for you. You could go on YouTube and find someone who sings better, but here's the quadratic formula song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can rewind that if you want to listen to it again, if you're like into self-torture. Okay, so I could solve this quadratic equation by factoring, but I'm going to use my quadratic formula for practice. So step number 1, it's set equal to 0. Step number 2, a equals 1x squared, b equals 4, c equals 3. My quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Write it, say it, or sing it every time you use it, and you won't be able to forget it. Okay, so this is negative regardless of the sign of b. So the opposite of positive 4 plus or minus the square root, in parentheses, 4 squared, minus 4 times a is 1 and c is 3. All over 2 times 1. So if you need to back that up and listen to it again to see how that all came together, then go ahead. Now we just need to simplify. So we've got negative 4 plus or minus the square root. Now be really careful with this part. This is called the discriminant. You need to be careful with your order of operations. 4 squared is 16, and then minus 12, right? All over 2. So negative 4 plus or minus 16 minus 12 is 4 divided by 2. Well, because this one would factor, our radicand, the number under the radical, our discriminant, this is called the discriminant we're going to see, is a perfect square. So the radical is going to be gone. It's going to be negative 4 plus or minus 2 divided by 2. because the square root of 4 is 2. Okay, so now, in order to get my two answers, I need to break that up. X is equal to negative 4 plus 2 divided by 2, or negative 4 minus 2 divided by 2. Again, order of operations, I need to add this first. Negative 4 plus 2 is negative 2 divided by 2, which is negative 1. Negative 4 minus 2 is negative 6 divided by 2, which is negative 3. So my solution set is negative 1, negative 3. And we would have gotten the same thing if we'd factored this, right? What are two numbers that multiply to give us 3 and add to give us 4? 1 and 3, right? So if we set that equal to 0 and solve, we'll hit x equals negative 1. If we set this one equal to 0 and solve, we'll hit x equals negative 3. You can always use the quadratic formula to solve, but if you can factor it, that's always going to be quicker, okay? Unless you have really big numbers. All right, now what about this one? So what I want you to do on this one is pause the video, find out what A, B, and C are, write down the quadratic formula, plug it in, and then restart the video to make sure you got the same thing I got. Okay, so I'm trusting that you stopped it. A is 3, B is 1, and C is negative 10. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This tune of Pop Goes the Weasel, right? So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 10 all over 2 times 3. So hopefully you got those plugged in the right way. Negative 1 plus or minus the square root of 1 plus 120. Right? Because a negative times a negative is going to give me a positive over 6. 1 plus 120 is 121 divided by 6. And the square root of 121 is 11. So now I have two answers, right? I have that x is equal to negative 1 plus 11 divided by 6, or negative 1 minus 11 divided by 6. So in this case, we're going to get 10 over 6, and both of those are divisible by 2. So that's 5/3. And then over here, we're going to get negative 12 divided by 6, which is negative 2. So that tells me that this one would have factored as well. Anytime you get rational numbers, either whole numbers, integers, or fractions as your answers, that means it would have factored. And if you wanted to, that'd be a good practice. Go back up and factor it and make sure that you get the same answer. So really, it's not a huge deal. You just need to learn that formula, and then it's going to help you be able to solve all kinds of quadratic equations. Any quadratic equation at all can be solved by using the quadratic formula. And factoring is a good skill too. You got to have it. Okay, so for these, the first thing I notice on this one is it's not in the right form, right? It's not equal to 0. So I'm going to go ahead and add x squared to both sides so that I will have x squared minus 4x plus 5 equals 0, right? Now I know what A, B, and C are. So go ahead and pause the video and try and solve this one on your own. And then restart it and see if you got the same thing I got. A is 1, B is negative 4, C is 5. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Write it, say it every time. You will learn it quicker. So be careful on this one, right? Because I want the opposite of negative 4 plus or minus the square root, in parentheses, negative 4 squared minus 4 times 1 times 5 all over 2 times 1. So plug it all in. You know, and if I'm going a little fast for you, remember, you can pause it and then restart or replay it, right? So that's nice. opposite of negative 4 is actually just 4, plus or minus the square root. Negative 4 times negative 4 is 16, minus 4 times 1 times 5 is 20, all over 2. So 4 plus or minus the square root of negative 4 over 2. And we can see that we're going to end up with imaginary solutions, right? Because we have the square root of negative 4. Anytime I see a square root with a negative in it, I know that's going to be I, right? So 4 plus or minus, the square root of 4 is 2, and the square root of negative 1 is I, all over 2. Now, the easiest way to get this is to go ahead and divide both of these by 2, right? So 4 over 2 plus or minus 2I over 2. So 2 plus or minus I. That is my solution set. A common mistake I see is people just divide the 2 into the 4. You have to divide it into both of them. Okay, so if you want to break it apart so you don't forget, not a bad idea. Okay, so if you need to pause it and watch that one again, you know, that's the nice thing about a video. What about this one? This is not set equal to 0, and these are not in the right order, right? So let's go ahead and get it that way. We're going to have a 2x squared. We're going to bring this over. It's going to become plus 5x. We're going to bring this over, and it's going to become plus 4 equals 0. Again, the same thing holds true. Can we factor out a GCF here? Nope. So what is A? A is 2, B is 5, C is 4. Once again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You'll thank me later when you can't forget it. So let's plug in. Negative 5 plus or minus the square root of 5 squared minus 4 times a times c all over 2 times a. Really, you know, just be careful when you plug in, and on your exam, when we get to there next week, remember to show all your work, right? So negative 5 plus or minus the square root of 25 minus, let's see, 8 times 4 is 32, all over 4. So negative 5 plus or minus, got to do that subtraction first. That's going to be negative 7 over 4, right? 25 minus 32. And then really the only thing I can do here is take into account that I've got that square root of negative 1, so I need to put the I out, right? So negative 5 plus or minus I square roots of 7 over 4. And because that won't simplify, that's my simplest form, that's my solution set. Okay, so hopefully this is starting to make sense, and it just takes practice, right? So if you're working along with me, that's going to help. When you go to do your homework, they're very much like these problems, so more practice, the better. Okay. Now you might be looking at this one and going, oh my God, it's fractions. But one thing that we know about an equation is if we multiply both sides by the same number, then it will be true for the same set of equations. So looking at these denominators, I've got 6 and 2 and 4, and the smallest number that they all divide into is 12. So I'm going to go ahead and I'm going to multiply by 12 on both sides. All right? And then I'm going to distribute that 12 to both of these. So 12 times, well, let's not do that. It looks like an x, right? 12 times 1/6 x plus 12 times 1/2 equals 12 times 3/4 x squared. Well, 6 divides 12 2 times. 2 divides 12 6 times. And 4 divides 12 3 times. So I've got 2 times 1x, so 2x, plus 6 times 1 is 6. 3 times 3 is 9x squared. And now we've created an equation that's equivalent, but now has no fractions. Now, we need it set equal to 0 too, so let's go ahead and subtract these to the other side. And we'll have 9x squared minus 2x minus 6 equals 0. Unfortunately, we don't have a common factor, so A is 9, B is negative 2, C is negative 6. So go ahead and pause the video, write it out, make sure that you get the same thing that I got. Okay, so of course, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 9 times negative 6 all over 2 times 9. So check and make sure that you have the same thing. 2 plus or minus the square root of 4, and this is going to be plus, let's see, 4 times 9 times 6 is 216 over 18. So 2 plus or minus the square root of 220 over 18. Okay. So this is not in simplest form. We're going to need to simplify it. So 220, the largest perfect square that divides it is 4. 4 times 55 divided by 18. And then the square root of 4, right? And then 55 is going to have to stay underneath. So you're going to have 2 plus or minus 2 square roots of 55 over 18. And then you could simplify this, right? 2 over 18 plus or minus 2 square roots of 55 over 18. And 2 over 18 simplifies to 1/9 plus or minus, and again, 1 9, square root of 55 over 9. And you can put it back together if you want, or you can just leave it like that. But the point is, you have to be really careful about how you do that simplification, right? On the exam, it'll cost you a few points. In Alex, it'll just be marked wrong. So they're getting more complicated as we go along. That seems to be the theme with this algebra class, right? Okay, now this one is a mess, right? So we've got to do some cleaning up first. We need to distribute over here. So 2x plus 20. Over here we need to FOIL, right? We're going to get x squared minus 2x plus 10x minus 20. So 2x plus 20 equals x squared. That's going to be plus 8x minus 20. We need to get it set equal to 0, so we need to subtract 2x and 20, right? So we'll have 0 equals x squared plus 6x minus 40, all right? And that one won't factor. I can't think of two numbers. Oh, yes I can. So this one would factor, but we'll go ahead and do it. So A equals 1, B equals 6, and C equals negative 40. This is good practice. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. If you want, pause it. Do it on your own. So negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 40 all over 2 times 1. Negative 6 plus or minus the square root of 36 plus 160 over 2. Negative 6 plus or minus the square root of 196 over 2. Now the square root of 196 is 14. So that tells me that this would have factored whenever I get a whole number there, right? So negative 6 plus 14 divided by 2, or negative 6 minus 14 divided by 2. Well, Negative 6 plus 14 is 8 divided by 2, which is 4. And negative 6 minus 14 is negative 20 divided by 2, which is negative 10. And right up here, we could have factored this, right? X plus 10, x minus 4 equals 0. And we would have gotten negative 10 and 4 is our two solutions, right? So bottom line is quadratic formula always works. If you can factor it, it's quicker, right? And then something that is an interesting fact to keep in your back pocket is something called the discriminant. So if I look at my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice that what's under the radical right here, b squared minus 4ac, that's called the discriminant because it allows us to discriminate what kind of solutions that we have. So if this under the radical is greater than 0, then we're not going to get imaginary answers, right? That means we're going to get two real solutions, one positive, one with plus, and one with minus. If it equals 0, right, if this is just gone, I'm only going to have one solution, negative b over 2a, right, because that would just be 0. And if this is negative, right, less than 0, we know we're going to have imaginary solutions, right? Okay, so these just, example 12 and 13 are just asking you to evaluate the discriminant and tell what kind of solutions. So before I can do that, though, I need to put it in the right order. So 4x squared, if I move this over, it's going to be plus 28x plus 49 equals 0, right? So b squared minus 4ac, b is 28, right? Minus 4 times a is 4, and c is 49. Let's see. So 28 squared is 784, minus 4 times 4 times 49 is 784. So that equals 0, which tells me I have one real solution. So if we factored it, it would factor like 2x plus 7, 2x plus 7 equals 0. Let's check. 2x times 2x is 4x squared. Outer is 14x, inner is 14x. That's 28 plus 49. So if we set these both equal to 0 and solve, we get the same answer both times, right? So one real solution if that discriminant, the number under the radical, is 0. So what about this next one? B squared, minus 4ac. Well, b is negative 4, minus 4 times a is 2, and c is negative 5. Watch your signs, right? So that's 16, and then that's going to be plus 4 times 2 times 5 is 40. Add those up, you get 56, which is greater than 0, right? So you have two real solutions. It's not going to factor because 56 is not a perfect square, but we will have two real solutions because what's under the radical won't be negative, which would give us the imaginary parts, right? Okay, and then there's one word problem in this section, and it's not so bad. So it says, NBA basketball legend Michael Jordan had a 48-inch vertical leap. Suppose that Michael jumped from the ground with an initial velocity of 16 feet per second. Write a model to express Michael's height above the ground t seconds after leaving the ground. So they've given us this. So all we have to do is plug the numbers in for this, okay? Well, they're giving us his velocity in terms of feet per second. So that means that we're going to use this value of g, right, in terms of feet per second. And that's going to go right there. And our initial velocity in this case is 16 feet per second. That is v sub 0. That's the initial velocity. And he's jumping from the ground, right? From the ground. So that means his initial height is 0. Okay? So let's plug in. S equals -1/2. G is 32. T squared plus initial velocity is 16 times t. T is the variable, right? Plus 0. So we can simplify that. Half of 32 is 16, so -16 t squared plus 16t. Okay, so that's the model that will give us his height. Now it says, use the model from part A to determine how long it would take Michael to reach his maximum height of 48 inches. And notice they told us 4 feet because our model is in terms of feet, right? So that's 4. That's S. So S is 4. 4 equals -16t squared plus 16t. Okay, I like this problem for a couple of reasons. First of all, it gives us an opportunity to talk about the fact that we need to move this stuff to this side because I want this number in front of the t squared to be positive. So if I bring that over, I'm going to get 16t squared. That one coming over is going to become -16 plus 4 equals 0. Just wash your signs, right? Bring this one over, it becomes positive. Bring this one over, it becomes negative. The other reason I like this one is they all have a factor of 4. So I'm going to factor that out first. That's going to give me 4t squared minus 4t plus 1. Okay? 4 times 4 is 16. 4 times 4 is 16. 4 times 1 is 4, right? And then if I divide both sides by 4, then that just goes away. And I have 4t squared minus 4t plus 1 equals 0. And I made my numbers smaller, right? It would come out the same if you didn't, but it sure is nice if they are. So A is 4, B is -4, and C is 1. And this time T equals -b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of -4 plus or minus the square root of -4 squared minus 4 times a is 4 times c is 1. All over 2 times 4, because that's a, right? So the opposite of -4 is 4, plus or minus the square root of 16 minus 16 over 8. Well, 16 minus 16 is 0, right? So we're going to get 4 plus or minus 0 over 8. Well, that's just 4 over 8, or 1/2 of a second. It only took him half a second to reach his maximum height. And that's an example of where the discriminant was 0, and so we only got one answer, right? And it makes sense because he only has one maximum height. So now we've looked at all the different ways to solve quadratic equations by factoring, by using the square root property if it's possible, only if we can isolate an expression with a perfect square on one side and a constant on the other. Or if we can't do that, then we can always use the quadratic formula. And for some quadratic equations, that's going to be the only way we can do it, because if we can't factor it and we can't use the zero factor property, that's the only way that we can get to the answer.